Well, hello there again, everybody, and welcome back to this crash course in formal logic. In this section, we're going to study squares of opposition in some detail, and it'll be helpful for us to make our inferences, our first inferences in deductive logic. Now, first up, we're going to study the modern, sometimes called the Boolean square of opposition. Even though Aristotle developed the earliest forms of categorical logic and the squares of opposition formulated in the Middle Ages were based on his work, I'm going to cover Boole first because he revises Aristotle's views quite a bit and it makes his square a lot simpler. So what squares of opposition do is they illustrate relations between categorical propositions, that's our A's, E's, I's, and O's, and sometimes the first square that we are going to study is called the Boolean square of opposition, or alternatively the modern square of opposition. So for the time being, let's bring in our A's, E's, I's, and O's and take a closer look at what George Boole contributed to logic. Now, the only relationship on this table that George Boole recognized was the relationship of contradictories. The A's contradicted the O's and the E's contradicted the I. And it's actually not too hard to see why that's the case. If you put the sentences right over top of one another, you have one sentence putting an X precisely where the sentence above has a space blocked out, indicating that nothing should be there. And the same thing goes for the A sentences and the O sentences. Now, two statements are contradictory if and only if one and only one can be true. And this is important for making inferences. If one is true, then necessarily the other one has to be false and vice versa. So that's to say they necessarily have opposite truth values. So the Boolean square only recognizes contradictories. All the other relations along the square are what we call logically undetermined. That means that you're not going to be able to make any inference claims across the top row or the bottom row, and similarly from the top to the bottom. Now, that may all seem simple enough, but actually it hides a very important logical problem that I'm going to discuss in some detail here. What Aristotle and Boole disagreed about was whether or not universal propositions, that's the A and E sentences, whether they made existence claims. For Aristotle, it's a definite yes. For him, if you say all S are P, that means there is something in the category of S, and all of those are P. And similarly, if you say no S or P, that means there are things in the category of S, and none of these are P. George Boole, by way of contrast, much later said, no, those sentences lack what would later be called existential import. All S or P just means hypothetically if there was an S, then it would be a P, and no S or P just means hypothetically if there was an S, it would not be a P. So you can see it better if we take a look at some specific claims. All werewolves are monsters, or no unicorns have two horns. And Gandalf is powerful. All these things fail to exist, but for Boole, all you're saying when you say all werewolves are monsters is hypothetically if there were a werewolf, he would be in the monster class. And when you say that no unicorns have two horns, what you're saying is no unicorns would be in the two-horned animal class. And when you say Gandalf is powerful, hypothetically, if anything was identical to Gandalf, it would be a powerful thing. So all these can count as true for Boole because they don't make any existential claims. Aristotle, by way of contrast, well, he's not going to allow you to have an empty subject class. So if you say all werewolves are monsters, then, well, where do you have to put them? You're going to have to put them right in that middle area. And if you say no unicorns have two horns, Aristotle is going to assume there's something in your unicorn class. I'll make a comment on that in just a moment. But it would have to be over here to the left. And similarly with the Gandalf claim, things work out pretty well the same way. So, Aristotle is not going to let you have an empty subject class to talk about. Now, on the subject of whether or not particular sentences, the I's and O's, make existence claims, both Aristotle and Boole are in perfect agreement with one another. Both assert that the I's and O's make existence claim. If you say state an I proposition, that's some S or P, you mean there's at least one S that exists, and it is also a P. So, Aristotle and Boole have a common understanding of what those sentences are going to be like. And if you state an O proposition, that means at least one S exists and that S is not a P. So the way that they write out their circles, if Aristotle ever engaged in that sort of thing. He seems to not use that technique, but their circles would look the same way. So you might be wondering, what's all the fuss, Aristotle? Well, some of you have seen this painting before depicting philosophers back in Plato's academy. Actually, Socrates was the teacher of Plato, and Plato was the teacher of Aristotle. Plato and Aristotle are depicted here. Plato was significantly older than Aristotle, and so he's the older gentleman to the viewer's left. You may notice that our painter here has perhaps worked himself into the painting, as well as many other notable philosophers from history. Well, Plato had a unique cosmology. It's interesting that he's holding the Timeo, which lays out his cosmology and theory of creation. For Plato, the ideal was the most real. So if you want to talk about things like circularity, justice, and other things, it's the ideal, or some people say ideal forms are located in Plato's heaven, that gives existence to the various circles that we see all around us. And the same thing holds for things like humanity, for justice, etc. So in his view, all we ever see are dim reflections of an ideal, and that holds for pretty much anything that you look at. There's no perfect circle in existence, there's no perfect justice, there's no ideal form of humanity, but we all have these sorts of properties, and we see them in the world around us because, in some sense, the things in the world around us participate in that ideal form that Plato was talking about. So part of Aristotle's project was to radically depart from his teacher Plato's views on this. Instead of having the concrete circles in our universe exist in virtue of some ideal or heavenly form, he wants to reverse that direction and make sure that any sorts of abstract objects or categories that we talk about, and notice I use the word category, any categories that you talk about owe their existence to concrete objects in the world around us. And if you think about it like that, you can see why he wouldn't want there to be any truth in a proposition of a universal sort, unless there was something that made it true, some concrete object in the world around us. So Plato's project is to emphasize ideals and their role in creating the world that we see around us. Aristotle keeps things down to earth with the particulars. So you can see why Aristotle's not going to be able to accept Boole's table of opposition. Boole's table leaves the relationships between the A and the E sentence at the top of the table logically undetermined, which means they could, for all logic tells us, they could both be true at the same time. But watch what happens if that occurs. Automatically, that gave you an empty subject class. And similarly, if the I and the O sentences were both allowed to be false, well, because the I and the O are contradictory to A and E, then that means if they're both false, the A and the E would have to be true once more, and that gets us back into the same problem. So A and E cannot both be true, and thus I and O cannot both be false. Aristotle once again wants us to keep us from talking about empty subject classes, as if those subject classes just hung in the air like Plato's forms or something to that effect. So you can tell from where I put X's in the E and the A sentences on this chart that no longer can we say that that relationship between the two is logically undetermined. And the reason for that is each sentence puts an X right in the spot that the other sentence has blacked out. So this logically undetermined relationship has to give way to the claim that both cannot be true at the same time. And we can't say that the sentence at the bottom is logically determined, the I and the O sentences. The reason for that is if each of them are false, well then, in virtue of the fact that they're contradictory to the sentences at the top, that would make both of the sentences at the top true once more, and we'd be back into the original problem. So we'll have to put a new relationship at the bottom. Let's just say both cannot be false. And the same thing goes for those sentences at the sides. You can tell if the sentence at the top, like an A sentence, is true, the I sentence has to follow from it. And if the E sentence is true, then the O sentence pretty much follows, because they put X's right in the spot where, where the other sentence put it. And consequently, if the sentences at the bottom are false, then they're going to prove the falsity of the sentence at the top, because the sentence at the top involves the same existential claim. So let's do a little bit more investigating. All these relationships have names. Just like we put the term contradictory through the center, the sentences at the top are called contrary. If somebody is contrary to you, you both can't be right at the same time. And at the bottom, we have something called a subcontrary. There's no good reason for naming it that, except that, it is sub, like a submarine is underwater. This is underneath the contrary relations. And the relationships down the side, whether you move up the chart or down the chart, are referred to as subalternation. So we'll talk about those in a bit more detail. So essentially, you can prove more with Aristotle's square since he has the no empty subject class assumption. A lot follows from that. Take a look at the example at the bottom. If A is true, then on Aristotle's square it immediately follows that E is false because they're contrary to one another. It also follows that I is true because A involves an existential claim that I was making. And it also follows that the O sentence is false in virtue of being contradictory to A. The only relation that Boole would have justified from the truth of A would have been the falsity of O. So we get a lot more inferences validated on Aristotle's square. And again, try this example. If the I sentence is false, well then A involves the same existential assumption that I makes, so A would have to be false as well. E would be true in virtue of being contradictory to I. It's going to take the opposite truth value. And look at the O sentence. Because you can't have falsity in both of the sentences on the bottom, then if one is false, then the other one has to be true. Again, the only inference that Boole would have justified from all this is the move from the falsity of I to the truth of E. Now, not every inference is going to be validated on Aristotle's table. There are fallacies in Aristotelian immediate inferences that you can make on this table. For example, there are names for bad moves along the Aristotelian square. They all tend to have the word illicit. When somebody tries to use a contrary relationship between the A and the E, and they do so badly, that's called illicit contrary. That's when you move from the truth and falsity of universal sentence to universal sentence. And that occurs sometimes if people assume that just because both of them can't be true, that they can't both be false, and that's not the case. And illicit subcontrary, that's just when you do you try to use the subcontrary relationship inappropriately. When you move from the truth and falsity of particulars to particulars. Remember, they can't both be false at the bottom of the table, but that doesn't rule out them both being true. So watch out that you don't make a mistake in that assumption. And then, of course, for the last relationship that we just studied, illicit subalternation is when you move from the truth or falsity of universals to the truth or falsity of particulars, or vice versa. Now, not every inference on the Aristotelian table is going to be justified. Do some practice with these. If it's false that all comic books are a work of art, can we claim then that no comic book is a work of art? Well, notice, this moves from the falsehood of an A sentence to the truth of an E sentence. There's nothing in Aristotle's logic that rules out both the A and the E being false. And similarly, if some wars are morally justifiable events, does it follow from that claim alone that some wars are not morally justifiable events? Notice the person's moving from an I sentence to an O sentence. Now, we know that the sentences at the bottom of Aristotle's table, they can't both be false. But there's nothing that rules out both of them being true at the same time. So the move from the truth of one to the truth of the other is an illicit move, illicit subcontrary. And there's one last thing that we need to cover. The absence of a formal fallacy is not sufficient for validity in Aristotle's system. And maybe this is a detriment to his system, but there are existential issues that can invalidate an inference, and they have to do with something other than mere forms of arguments. Take a look at this. All unicorns are animals. Some unicorns are animals. Now that looks like a move from an A to an I sentence, but we want to lose arguments like that and say that the conclusion did not follow. After all, unicorns don't exist. But all cats are animals, therefore some cats are animals? Notice these two arguments have the exact same form. Aristotle wants to keep the arguments at the bottom and lose the ones like the unicorns example. And that means he has to introduce something into his system other than a formal element because these arguments have the same form. Existential issues, the fact that unicorns don't exist, can invalidate an inference for Aristotle's system. And it's an issue other than form that probably is a detriment to his logic. So, in summary, these squares can be used to determine whether an immediate inference, and I've used that term before, basically it's an argument from a single premise to a conclusion, and you can use these squares to tell if those arguments are valid. Now, arguments that are valid from the Boolean standpoint are called unconditionally valid, because they don't have to depend upon finding out whether the items talked about in your subject classes and your universal statements actually do exist. And Aristotle, by way of contrast, along the outer, making inferences around the outer edge of the squares, may be validated, but you have to make sure that they don't commit any existential problems, making incorrect existence claims, because a lot of those inferences located in the brown along my diagram at the top depend vitally on the legitimacy of those existential assumptions. So, if you can use Aristotle's table, but those arguments are called conditionally valid. They're only going to be valid on the condition that the things talked about in the subject classes of your premises, when your premises include universals, that those things really do exist. So consider these arguments and try to figure out if they're valid and on which square. It's false that all private eyes are masters of disguise, therefore some private eyes are not masters of disguise. Notice I moved from the falsity of an A sentence to the truth of an O sentence. Now if you stop to think about it, those two sentences have to take opposite truth values. That's one of the lessons we learned from Boole. We don't need Aristotle's arguments to prove that to us. Now consider the argument on the bottom. No meteor showers are daytime events. That asserts an E sentence. Therefore, it's false that all meteor showers are daytime events. Well, since those two claims are contrary, but only on Aristotle's square, then we have to say yes. But we're going to have to say that it's conditionally valid, because it's using an inference that's only validated on Aristotle's square of opposition. So when you move from one of those claims to the other, make sure that the objects talked about in your subject class exist. Consider this argument. All cell phones are wireless devices, therefore some cell phones are wireless devices. Well, that seems like a good inference, but only based on the claim that we know cell phones actually do exist. So from the Boolean standpoint, this argument would commit the existential fallacy. This is a form of argument, the move from A's to I's, that he does not accept because he's willing to permit empty subclasses. So for Boole, the premise lacks existential import, but the conclusion snuck it in. The premise did not include the claim that cell phones actually existed, and we need that assumption to get the inference to go through. So here's my little cheat sheet for you. The Boolean square of opposition at the top and Aristotle's square at the bottom. Feel free to look back and refer to this at any time. And let's move on to the last issues we're going to cover. Let's try a few applications. Try this one. All cats are animals. Does it follow that some cats are animals? Step 1. Is this valid on Boole's square? No, it doesn't, we said, because his premise lacks existential import. But Aristotle recognizes existence claims involved in the universal sentences. So, last step you have to check, do the cats really exist? Yes, they do. You can stop. This argument was valid after all. Or try this. No witches who fly on broomsticks are cowardly women. Does it follow that some witches who fly on broomsticks are not cowardly women? Well, here we have a move from an E sentence to an O sentence. And of course, step number one, Boole's square will not justify that. By way of contrast, Aristotle's square, step two, will justify it. Are there any witches out there? Let me add the caveat. Ones who actually fly on broomsticks. The answer to that question is absolutely no. So this argument is still invalid. And the same thing goes for no wizards with magical powers are malevolent beings, so it is false that all wizards with magical powers are malevolent beings. So here we have a move from an E sentence to the falsehood of an A sentence. Now that's an interesting move. Well, for step number one, we know that Boole's not going to justify it. The E's and the A's are logically unconnected in his view. Will Aristotle justify it? Well, he won't allow both sentences to be true at the top of the table to be true, so you can move from the truth of one to the falsehood of the other. So Aristotle's square will justify this inference. However, by way of contrast, we need to go to step 3 and check and see if there were any existential issues involved. There are no such things as wizards. Well, at least not ones with magical powers. Well, I think you've mastered everything you need to know for now about categorical logic. Congratulations. You're going to be doing immediate inferences, pardon the pun, almost immediately. So stick around for more logic lessons, and I'll have another video for you here soon. Take care.